All right, so we're talking about network topologies today. We did a little bit on the board yesterday where we talked about like bus and star and mesh and stuff like that. But it's important when you're looking at networks, and this is what gets a lot of people hung up, is there's an idea of a physical topology and a logical topology. So what do you think the difference is between those two things? Yes.
I picked a very bad time to put my hand up, but physical is what you can see, and logical is how it works.
Sure. So we could have a bunch of switches in this room, but and that would be our physical topology. But the logical topology could have 6 or 7 different departments that kind of loop through here, right? Because we have different VLANs on the switches. Okay. So a couple older technologies that you need to know about, and these are our physical kind of layouts or our physical topologies, are bus, where everything was kind of connected to a main line, and then there was like a terminator at the end. And then the other one is a ring, where everything was in a kind of circular function. That's how they were all connected together, okay? These ones aren't really used anymore, like we talked about the other day, in that they're not very efficient at delivering information. They're not very secure. They're slow. And Ethernet has kind of advanced to a point where these are just not really even useful any longer. So network topologies, go through real quick. We talked about the rings yesterday. So with a ring network, you would have a token ring that would be passed around, and it would say, who is this information for? And then if it was for you, you'd be able to interact with it, and then you'd ship your information back up and send it around the ring as it goes. As far as like the actual network plus is concerned, there might be a question that's like, what is an older technology in which everything was connected in a circular fashion? Well, circle equals ring. Like, that should be a pretty easy one. But they're not going to go into, as far as I know, like a deep explanation of how token ring networks work, okay? The more common one that we see now is our star topology, which is what you see on the screen. So with this topology, you have kind of a central device, and then everything is connected to it, and then it's part of a larger star, which is part of a larger star, which is part of a larger star, and that is kind of how the internet works. This compared to a mesh topology, so at the higher ends of the internet, it'll migrate from kind of like the star topology to more of a mesh topology, so there is redundancy. Okay, so that's your biggest advantage with a mesh network, is if one link goes down, that you still have the ability to maintain connectivity. Because if you look, if we severed the network right here, we still have alternate paths, so we could go from here over to here. Does that make sense with a mesh network? Where you most commonly will see mesh networks, yeah, you'll see them at like the higher ISP levels. But you'll also see them sometimes with wireless as well. So the wireless networks, especially with, like, you're trying to cover something very large outdoors, so like a fairground, let's say, they'll use a mesh network in order to have multiple paths as far as like bandwidth, so that way if something goes down in a remote location, there's other ways for those clients to get access. So think like campgrounds, think like fairgrounds, any large outdoor spaces where they don't have the ability to run physical cables. That's where you're going to see a wireless mesh network, okay? So just a quick review. Why are protocols important for networking? With the example that we gave yesterday about like talking. Do you remember that? And language. So what is the advantage, or why are they important? Yeah.
They're important because it kind of defines what you are. You know, like, for example, something like, it's kind of like how you see a person, right?
Yeah.
If you like talk to a person and you see who they are, that's like kind of like a protocol. So
Mhm.
tell what you are.
Absolutely, and with that person, understanding your audience. So again, if you speak Spanish and I speak English, we're on different protocols, right? We're not going to have good communication. But if I'm sending you information in, say, English, and you understand English, you know how to de-encapsulate that information, process it, and then send information back out. What are the advantages of a client-server network as compared to a peer-to-peer network? Yeah?
So wouldn't peer-to-peer be faster, but then client-server would be like more widespread?
Yeah, so peer-to-peer is not as scalable. Is it faster? Kind of, if it's like a small
In
office.
terms of like setting up.
Oh, yeah, yeah. So as far as speed of setting up, absolutely, because I can simply plug a.
You set up those and they connect to each other. You have to like set up the server, have everything on it, and then have all of those be connected to that.
Correct. And it usually takes a lot more work with like a client server network as well. But long term, the client server model is more redundant. It's better as far as scalability. It's just kind of become the standard. And you'll have a small business that will most likely start off as a peer-to-peer network because they just want to share a printer out, or they might even have like a network attached printer. Okay. But at some point, they're probably going to need to add on storage, or they're going to add new applications. So that's when they're going to have to kind of migrate to that client server. Do you have a question?
No, it says what are the advantages. I feel like another advantage here would be that like everybody has easy access, and if the file, like, if like a computer crashes and the corruption happens, like corrupts all the files, you don't
Yeah.
have to worry about it backed up.
That's a really good point. So with a peer-to-peer network, you have maybe a secretary that has her printer shared out, and if she gets a virus, or if she has data shared out, if she gets a virus on the machine, then you put the entire company at risk, right? Whereas client server, you have less likelihood to get a virus because you're not browsing the web. I mean, short of something being installed on the server that had malware attached to it, the ability for a virus to spread is a lot smaller, right?
I feel like it's also good to note that like I feel like a server will probably have a better firewall.
Yeah, so servers, when you're installing, you'll see once we get into that, you have to, like every single step of the way, you have to accept it like 5 times before you actually do anything. So what's defined by the logical topology? Or topology, wow. Yeah.
How everything travels through.
I made it to P.
So what is defined by the logical topology? Yep.
So like the physical explains like how it's all set up, but the logical explains how things actually transferred.
Yeah, so how it's actually used, right? So the physical topology is going to be where it's located, and the logical is kind of how the actual items are going to be used for different departments. We didn't really talk about this very much, but we'll talk about it now. Why is a physical mesh topology normally impractical? So having a mesh topology where everything's all connected.
That would take a lot to set up.
Yeah.
That, like a mesh has to be at least what, 3, ideally 4 computers.
Yeah, depending on how many are in the mesh, depends how many connections you're going to have to everything. So to have
The more you
wires
have,
going.
it's gonna get
Right.
more and more chaotic, and
So it doesn't make sense for us to do it here. Now, at the ISP level, where those aren't necessarily like PC nodes, but they're like router nodes, that makes sense because we can set up routes very easily to those other nodes. If one goes down, we have ways to go out. But as far as like actual like PC or server nodes, or for us to have that level of redundancy, we don't really need it. We're not that important. Number 2, just for us to run all those cables everywhere, it's just super cost prohibitive. Okay, so so the OSI model is what we're going to talk about next. I think that right now we're probably a little late in the day for a heavy topic. So go through and knock out the quiz and any of the assignments that are in that first kind of 2.1. Get those knocked out. Because I want to start fresh with the OSI model, because this is a core thing that you're going to have to know for the for Net Plus, but also once you go into like Security Plus and stuff, you're going to have to know the different layers and kind of where to set up your attacks, okay? So just a short lecture today, just to finish up what we didn't get to yesterday. Make sure you're totally complete up to 2.1, and there should be a quiz there, and then we'll move on tomorrow. Awesome.